Hello, welcome to the stream. I'm Jun Chan, and we're back doing some more explorations on Comonats. And yeah, it's the 10th episode. And I think I'm getting some handle on Comonads, maybe. But still not quite to the point where I suppose I've refactored Phil Freeman's PureScript React Explorer to something that I feel comfortable with. I got it to the point where I suppose maybe we're getting close to having this kind of interpreter that maybe will have a base in effect or IO. So that's what we're going to continue doing this time. So let's get back to it. I suppose we want to do our log rigmarole like we usually do. Oh, there's a bunch of stuff that wasn't saved. And yeah, duplicate. We are from August 19th. Time flies. And we are still doing Comonad. So let's see. Yeah, I think I didn't update my to-do last time, but that's because we were we had one case of it compiles but it doesn't work, which is always an interesting occurrence in functional programming languages. So let's check what's up. So the oh yeah, that's fine, but that's not what I'm interested in. What I'm interested in is the other screen right here. There we go. Okay, so yeah, the thing is that @counter all of a sudden didn't work anymore. So let's see what's up with that. I see that oh, there's a type T not have kind type. Oh, did I change the signature of component? I believe I did. Hold on, no, I didn't. WA. No, I ended up not doing that. What I tried to do, oh yeah, I did. Oh yeah, no, I did. I added a to component. Yeah. So, was that a good idea? It's because I wanted to keep explore polymorphic in component here, but couldn't I have used WUI co-W unit A? I suppose I probably could have, right? So let's try and do our .react element here. It's going to be a little bit less readable, but let's try. But maybe at the same time it will reveal something about the shape here. Blah. A. Probably don't need. Oh yeah, no, I don't need that one. And A. That work? No, there's a missing parenthesis somewhere. Yeah, that guy. So W needs to be around the A. And yeah, now component W is back to its original type. And so that should mean that, no, we're still not good. There's still an error here. UI, DDD. Component list space. Co-list space units. Interesting. I don't think I changed UI, right? Oh, action A. I did change UI. Interesting. Yeah, I did that to surface this. Hold on. How was it before? UIA are direct elements, and UI didn't have the. Yeah. Okay, so how do we refactor that? Okay, we could further unroll UI so that it's handler action to A. So it's going to be handler action to co-w unit. No, it's going to be handler, right, it's going to be handler co-w unit to A. Yes. Okay, so that's going to be handler co-w unit to A. Handler co-w unit to A. That still doesn't work. How's this? Hey, this seems to compile now at least. And hey, look at this. We're back to working. So it wasn't the case. It wasn't type checking. So it wasn't one of those cases in functional programming where it type checks and it doesn't work. So good. Right, so that's not too bad because it kind of starts exposing that CPS shape. And it kind of makes me want to also unroll handler, to be honest. So let's unroll handler. Because it really means, so handler is going to be this, right? I think so. Yep. So yeah, I mean, it's really ugly. It's really hard to read. I might want to keep the handler version at least as a comment. Shall we align it? Yeah, no, I think I need that, and I need that. So we have a comonad of this kind of CPSE thing, and a comonad of this CPSE thing to effect unit. But this CPSE thing really is kind of the polymorphic component, right? So maybe we can annotate this. This is kind of component prime WA, right? With, if we say component prime is something like that, where UI prime is type UI action A, which is handler action 2A. And I think when we looked at Comonadic UI here, it was indeed parameterized in that A. And it meant that but component React UI was parameterized by React element, and then React component was using, oh, actually it wasn't using React UI, weirdly enough. Oh yeah, that, okay, but it's to avoid the type error that we had here, where it becomes React UI here, and then you have here, right? In a step here, UI, UI.react, React UI. Yeah, it's equivalent, right? It's in the step or the render function. Yeah, I suppose here the yeah, it was called eval instead of step. Maybe eval is not a bad name, huh? Because indeed it won't be, we won't have the, it won't be an interpreter there. So let's call it eval. And then it did, instead of build cofree, it did unfold cofree. Where does that come from? It does come from cofree. Let's take a look at unfold cofree versus build cofree. Yeah, it just doesn't use the tuple. So maybe that's just slightly more elegant somehow. It might mean that we skip one step there, and that might be a good thing, right? Because build cofree step funct, that's not very nice. So let's yeah, let's use this. I like it. There's some build cofree here though, interestingly enough. But there's unfold cofree, and it takes I suppose UI, which, yeah, I guess we can call render. I think that's very reasonable. And then eval, and then init, which will be count 0. And so transforming this into unfold cofree. And that means that really that's our counter now. And well, it means we kind of hide the types, and maybe that's better, because this is a bit ugly, to be honest. And then we say this, and would that just work? Cannot match cofree with that function. Because of the init here, which I need to think about for a sec here. Yeah, no, eval takes count, so I think that's good. We actually don't need to pass count here, and it should just work. And non-value, yeah, it's just that count that we don't need, I think. But then we can't show count here. I know, because render in that case can't take count, and that's magic, but that's good, because I suppose it's that unfold cofree. Does this mean unfold cofree actually then includes a state? Yeah, this whole thing is really about passing states, isn't it? Like you need, and I wonder whether that's a more theoretical question. Let me put it somewhere in our log. State. Yeah, I think it's not about that. Not about that. Okay, let's do a new thing. Comonads and iteration. So I want to paste that. that feels like, well, hold on one second. I do want to check out this, oh boy. Comonads and lenses. I need to read that. And I think right, recursion schemes. Recursion schemes for Comonad. Here. Okay, maybe we need to see the recursion scheme library. Base, if I remember correctly, is the iterative nature of things, such that there's an instance of base for things like fix and cofree actually. And but that somehow, for me, obfuscates a bit of what's going on. But I see how it's generalizing at the same time. But we're supposed to be unfolding. And A to, we take an A. That's, I think that's what we're, it's a post-pro, I think. Except it creates a cofree A. I think, I mean, maybe, right? Is this similar to this? I don't know, but let's not look at it right now, because I think, oh, unfortunately that doesn't work though. Ah, yes, okay, because render needs to take a counter model, and then it should be fine, right? Yes. It is fine. Good. And let's take a look at whether the type, yeah, it did show up here, and eval, yeah, of course it does. Yeah, so I mean, the fact that we have like a state career here makes a lot of sense. But then the question is, how will that interface with Explore? Because right now we have this Explorer, but I was thinking that maybe we could revert to Explore M, maybe. And by the way, this is not pairing, so I need to fix that. And just do this. It's not pairing because it's going to have some monadic M. So I suppose I could ask whether is that a residual pairing? Is that residual pairing? So here I'm using interaction law residual. And maybe we have some slides for that somewhere. Yes, we do. So I think the monad-comonad interaction law is pretty much what we're doing here. And specifically, residual have this R, which is a monad. form a monoidal category. Maybe it's not a monad. Maybe it can be whatever we want. But, it's a R residual. It's a functor, but in our case, we'd say it's a monad, and I think that's probably fine. It can be more than a functor, right? Oh, relation to effect handling. R residual monad-comonad interaction law of TD, T being the monad, D being the comonad, explains how some of the effects of a commutation that dealt with by the environment, some are left alone or transformed. So yeah, residual, it's okay, they're talking about a residual effect handler, but that sounds more like what's happening with pure script run streaming, really. Meaning we consume like a variant, and then there may be some variant that are not consumed at the end of the stack, and then maybe the R thing handle those. I think it depends. Maybe we can put, yeah, I don't know, but I think this is my interpreter. I'm going to link here, but I think this is what I call the interpreter, and it allows me to keep my monad, my comonad, and my monad pure, but still to use whatever is happening at any given monadic-comonadic interaction to define how I do my effect in the base monad. And I think that's where I want stuff to be. So can I transform this in that way? So, well, one thing to note is that in some sense, we're, after having expanded to PureScript React Explore, which does this correspondence between Halogen and React and like Purview, and now maybe we're specializing only to free co-free, and that is what will allow us to use Explore-M. It's because I don't think, yeah, because that wouldn't work for, I mean, that is specifically possible pattern matching on the base functor, which allows us to sort of like escape the loop abstraction and act pointwise on each iteration of the loop, which is so much easier to write, and we leave the looping to Explore-M. But we are specialized to free co-free. So it could be that we need to define a new type of component that actually sort of clearly doesn't allow W to be any comonad. So we'd say maybe this is component W, and then we do a new type component G or F, or yeah, let's say G, which would be co-free G of UI co. Yeah, co-free G unit. And then we need to import co-free here, but maybe we define this as like a different thing. Say this is explore G. For now, let's leave it here. Because so far, yeah. Okay. So. Yeah, why not? And do this and import co-free here. And so now we have a component. Yeah, that's going to change quite a lot. I'm surprised this compiles actually. We just need G to be a functor now. Oh yeah, I suppose we could say also that it's component W co-free G, right? We could say that. That would be fine too. But then it means that now this is just a functor G. For all G. That's fine. And then here, if we want to actually unroll this, we'll need to write the co-free G here. And here too. And G. And co-free G here. Okay, and then in main, that shouldn't work, right? Yeah, no, it doesn't work. And that's because component now is based on the list interface. Meaning we don't need list space anymore in practice. We should only need list interface, which probably should, and then right, except here, right? Here possibly we would, but we could say co-free list interface and get on with it. And that would be list interface. And here as well. Interfacer, nope. Okay, and same thing here. We would need to let go counter space. And I think in that case, really, this should just be counter, don't you think? Yes. I mean, yes. If we say that that's yeah, let's say that it's counter. Less is more. Okay, here co-free counter, and here co-free counter. Counter and counter, and then component counter, much prettier, counter, counter, and here co-free counter, and then the same spirit. Well, list list is not as nice because we don't want to overload lists. But what's our problem now? Counter space, that's fine. We say co-free counter and counter and co-free counter. Oh, I wasn't expecting that. Coty counter with type Coty Cofree counter. What am I missing here? Or maybe it was just counter. Yeah, probably it was actually. Up. Yeah, and then list with yeah, I think list with Cofree is just list of counter. No. Hold on. List Cofree counter with type Cofree list counter. Right. That's because of type of list, right? List dot. This exports list as this thing. So we need component G, or maybe that's fine. Maybe we use component G for that. So we import not in Explorer, but here. Let's oopsie. And I was saying we import component G as well. And we export it. W, yeah, component W, not G. I thought G is generic. And then we try and match that type by saying this is really a component W. Is that right? And in that case, it takes Cofree counter. Yeah, and then, but then React Explore needs a W if we want to be able to. So, yeah, I suppose lists, maybe I need a Cofree list, right? How's that gonna work? I need something such that list okay, let's give it a shot. New type list GA equals Cofree GA equals list Cofree, and then sum might be sum of identity, and date W it's going to be Cofree G. No, but that's not exactly that, right? Hold on, sum. I think I might need to start with sum. Sum of two comonads. I'll need the sum of two Cofree comonads such that if I get the sum of the base functors, then I get the base functor of the sum. this mean I need some kind of type class for this? Like wrap co-free or something, monad co-free. Maybe monad co-free, yeah. Maybe if I have a monad co-free instance for also for list, then maybe I can wrap co-free or something, and it will just work. It's possible. Let's see where our monad co-free, monad free thingy lives. That's the monad. That's monad free. I want monad co-free, right? And where is that gonna be? Monad co-free. Class Comonadic co-free and wrap co-free. All right, let's try that. Let's try with sum first. I think I'm going to need that. Instance Comonadic co-free sum, such that if you have a functor f and a functor g and a comonad w and a comonad u x, then we have comonad co-free of some wx, where is that right? Oh, comonad co-free. Oh, right. Huh. I'm not sure I can express that. Because the fact that we have something of kind star is going to be a problem here, I believe. Pretty sure. Because here we want, we kind of want maybe some other sum. Oh, maybe that would work like that. If we say like sum of the pattern functor or sum of the base functor, or even of the functor actually, because that's a more common way to interpret things. So we'd say if f is the base functor of the co-free comonad w. Oh, right. So yeah, we need to say also comonad co-free f w and comonad co-free gx. Woof. That is a mouthful. So if f is the base functor of the co-free comonad w, which is a comonad, and f is a functor, and g is the base functor of the comonad x, which is a co-free comonad, then we want to say that there is a co-free comonad. We can write that the base functor is some ffg for the co-free comonad for the monadic sum, the comonadic sum of W and X. And to say that, we need to say what sum F is, or is we saying like for sum F? I don't know. But basically, we need to then write a unwrap co-free which can be specialized to this. So we pattern match on the broader sum, and then we try to extract the base functors from this constructor, depending on whether we go left or right, and probably with just unwrap co-free of the it's pretty easy to write, I think. We pattern match, and if it's true, okay, are we doing this here? Here we seem to be ignoring the Boolean, which is weird. It remembers the other state, and we can move from one state to another. But where is, okay, B is used, there we go. Yeah, here, true, false. Okay, so we want something like that. Then wrap co-free. So we pattern match, but then our FA, to be honest, I think we can just unwrap co-free here. But we just need to then rewrap it. But we need to know what our sum F is, right? But sum F is just going to be, could it just be pair or there's a semantics question here too, I think. So we remember the states, and we can shift the whole comonad left or right. What does it mean when we change only one step inside the co-free functor, inside the co-free comonad? And yeah, I suppose we just put the bool, and so let's define our type. Data sum F. It's going to look exactly the same, to be honest, but sum F. Shall we therefore? Yeah, you know what? It looks like it's exactly the same. I don't think we need to call it something different here. You can just say that there's a sum of so hold on, unwrap co-free FA. We'll put an F out and leave me with the FA, or the F, or we leave me with the WA. Oh, but then oh, that's interesting. Yeah, there is a important semantics question here, but I think we need to also unwrap GA, because we can't leave the other comonad not moving forward in time, or can we? Interesting. Yeah, well, it depends whether we allow the component that's in the back. So let's say that this is a way to sort of like have either one component seen or another component seen. Then okay, let's say we have component A at the surface. We send it monadic free function, free functor actions in the base functor of A. So it moves forwards and does its thing. Cool. But then if the user starts, or maybe actually not the user, because the user maybe doesn't have access to B, but if stuff in the background actually is trying to reach B, then do we just ignore them? Maybe not, right? Depends what we want our semantics to be. If we say, no, it's just hidden, but if B receives stuff in the background, then it should, I suppose we could say it's queued, or it actually just executes in the background, and such that when it shows, it's actually already at the right state. So I think in that case, then we need to indeed unwrap both. And in such a way where this gives us FWA, and this gives us, okay, you know what? Let's say where FWA is this, and GXA is this, right? Now the question is, how do we go underneath? We need to sort of fmap underneath both, right? So is that apply? Maybe it's apply, right? So do we do just some FWA apply to GXA? And what's your dealio? Unknown type class Comonad co-free. Sure. We need an co-free, right? And right, yes, yes, so that should be true. Oh, so maybe it worked. And then in fact we just say B and some B and we're good to go. No, because I think we have also some inside, and I think now we have, what's the type of this? It's sum of the Boolean, and we go underneath 1f. Not even sure what that ends up being. We need some FG at the front. It seems like we kind of have some of these, just that maybe we don't have some WX. Is that the problem? Because that's of type unwrap free FA. This should be called W, shouldn't it? And WA and XA. And when we unwrap co-free, then we do have an F of a WA. And here, GXA of a G of an XA. Let's see if that's true or not. The variable A is undefined. That's true. We can say for all A here, I think. And we then have some problem with A's. Oh, right. Yeah. No. Okay. I suppose I need to say for all A around here, I think. So that it's the same A. But we can't do that. So is that it? Is that here? No. Okay, let's not have types. Or can we have types? Can we do this? Does this work? No, it doesn't work. Does this work though? Even seems like it does. G with some FG. Yeah. Yeah. So on one hand, maybe with this sum, right. With this sum, we do get the F and the G to create the sum FG here. But underneath, we are stuck with what exactly? In fact, it's a bit weird, right? Because we're stuck with WA sort of, I don't know, partially evaluated or something. I'm going to take a little break and drink some water and stuff. Be right back. And I'm back. I'm not sure I'm going to last this long because I actually did get my vaccine today, and yeah, no, yesterday. But I'm like the lights are a bit hardcore on my brain right now, and they're giving me a bit of a headache. Okay. Oh, one thing we could do possibly is pattern match on. Can we pattern match? No, we can't really pattern match here. We just have a functor value. And yeah, we can, if we have a functor, we can fmap under it, or we can apply under it. But then this is hard without the types underneath. Maybe we need an operation on the functors here. Maybe we need to sum again underneath, and maybe we need to fmap, because we need to have this doubly wrapped, don't we? Is that even possible? Yeah, well, I suppose we'd have the same thing on the other end. So let's call this whatever, sum. And then, oh, maybe we don't, maybe it's just FWA and JXA. And then we go underneath the sum, but in both. No, that's not going to work, is it? Because we kind of want a sum that has the F in front, and then another sum that has the G in front. So that means that to have the F in front, does this mean we do this? We fmap? Is that even a thing? Do we use the identity functor somehow? But that's going to leave a new type, which we need to unwrap at some other point. I'm not sure that works. But does this make sense? Like that this needs to be kind of f sum and this needs to be g sum, where f sum will be f wrapping sum wx. I think this makes sense. So when we unwrap co-free, we have an fwa only, and we want an f sum wx. And so f sum would be yeah, wouldn't it be? Can we do this? Can we use a wildcard like this, or whatever that's called, FWA? If we do this, then GXA is we want XA here, not is that right? Yeah, I think so. We want the XA from unwrap co-free XA. But we can't do that, can we? Unless G is a monad, but G is not a monad. We can't extract a GXA from a GXA, extract an XA. Back to what I was saying about pattern matching earlier. But do we really need to do that? So if we succeed in applying this under FWA, then we end up, yeah, so one possibility is just to use the XA, but then it feels like we then wouldn't be advancing the XA. And I think that wouldn't give us the semantics we want, right? No, but hold on. Maybe it would, because some FG means that we would receive either an F or a G. So we can't update both at the same time. Okay, so in that case, it does work. And then we can say, we can pretend that we're smart by doing it like this. I mean, we don't know whether actually this notation is going to work, but we can probably find a way to make it work. WA and apply to unwrap co-free XA. So you're not, that's an anonymous function, but you can't do that visibly. Okay, that's fine. We can make it, can make one for you. And we'll call it W. And this one will be called X. And we don't have the right type. We're supposed to have W2X3. We're trying to match sum of some W2X3. So yeah, yeah. Yeah, but no, but that sounds like it should work. Let's type sum F0G1, sum W2X3. That's what we want. But then sum W2 ends up being matched with sum of sum W2X3. Yeah, that's, but there is a sum of a sum. Is that wrong? Maybe this is wrong. Maybe there shouldn't be a sum. I mean, this looks like a sum of a sum, right? Because if we unpack that, isn't it some? Okay, maybe, how about if I don't have a type here? Do you still think it's the same type? Yes. I mean, this is not going to be right, but some FG really is some Boolean F blah and G blah. So, okay. So there is a sum of a sum, right? And it seems right to me. What's wrong with that? Oh, maybe we don't need to go underneath. There we go. Okay, so what though? Now, oh yeah, of course. Now we need to write another list off because we now have a list of GW. We take the component W, and that's fine, right? If we import component W, yeah, that's fine. But now, if we want to do the same thing with a regular component, that's where we're in trouble. And that's where we're going to need another list thingy. Unless we are able to magically put out some type class magic to make this work, but I don't think that's going to be the case. I think we need to it's not going to be Comonad anymore here. It's going to be functor, and it's going to be G, and that's where we're trying to write. And then here we kind of have the question of whether we can have indeed a natural transformation from G to this G to G. That's one thing. And then here co is going to be co of co-free G. I think that we don't have a lot of choices on that. And we need to have co-free here. And G, let's say that for now we say it's co-free G, and get the feeling that this natural transformation is probably something known. Okay, not too bad. And then it's just that now we need to distribute or sequence. In this case, distribute. And how do we do that? Co-free list and list co-free, right? So we need, yeah, we need a distribute instance, FGA to GFA. Sequence or distribute. So I think, yeah, I think I think we're more in the spirit of distribute, because sequence is for effects, and that's not really what we want. It says the dual of sequence though. Interesting. So we need both distribute and collect. No, we need only one. Okay, that's cool. So if we have a collect, yeah, maybe one of those is going to be trivial to write. So let's see. Probably we'll want to say distribute, and then we want to import distributive, and then we'll want to create an instance. Maybe there's already an instance. No, there won't be, because it's an instance for lists. So we need to say instance distribute list cofree, where it's distributive, and I think we're saying oh, it's for all functor G. Hold on, distributive is not between two things, it's only between, it's only everything F. It means that for any F you can go underneath, but hold on, there must be a distributive instance for cofree then. No? Hey Chris. Distributive, port data distributive. It's possible for a specific functor. That's not gonna work for us. Cofree distributive. Yeah, this cofree is distributive if F is distributive. So okay, so we need to have a distributive instance for our functors as well. So we're going to have to carry a distributive instance for a base functor. In practice, that might be fine. I mean, in theory, that might be fine. In practice, I don't think we can derive it. But let's try. Distributive from data distributive. Not derivable. So what does it look like in practice? It should be fairly simple. Maybe. Let's try one. AG functor G, because it's going to be easier to do it with a simple functor. Then we'll try to do it with the general case. So we have a G surrounding an FA, and we want to end up with an F surrounding a GA. So we've got a counter with a change count in it and an increment in it. And the change count is from int to FA. And so we need the distributive instance of function. That's prim function, so it should just work. So we can distribute, hold on. What's the outer shape of this? We don't know. It's going to be some f. We can distribute around a tuple, but we can't distribute around a maybe that's fine. Maybe we use the tuple instance to distribute over change count and increment, and then we rebuild some. Do we need to rebuild a record here? Is what I don't know. Let's say FA is a list. So we have change count is an int of A to a list of A. So now we want a list of GAs, a list of these records. Yeah, so we can't really get at it that way. We can't really get at it that way. We have to say distributive of X. And we have to know that it's of form counter blah. And we have to go underneath it. Maybe we can transform it into a tuple. Does it make sense though? And then we unwrap. No, it doesn't make sense. Doesn't make sense. So I suppose we want to fmap distribute, right? No, it's not that either. So we imagine we have a counter of, okay, let's write it down. We imagine we have a counter of change count of int to list of A and increment of list of A. And that we want to have a list of counter cc inc somehow. Not exactly that, like with a different cc, right? cc that's into a so we need to distribute over something. If type equals A and unit, oh, then you have a distributive for tuple A. Okay, I see. Yeah, so yeah, that makes more sense, but it's weird. Should we just try and collect instead? What would collect be? Collect would be this crazy thing. Which for us would mean something like from, let's say, an A to a list of B. which I suppose is singleton or something, and then a GA, which would be a oh, hold on, I'm doing it reverse. Oh boy, I'm doing it reverse. That's why maybe I'm struggling. Okay. So we're going from a G is the list. So we're going from the list of an FA, which to the counter of the list of blah. Okay, so maybe that's going to be more easy. Yeah, because then in that case, I think it makes sense to pattern match. It's a slightly different. We don't need to collect, I don't think. But then we know we can construct a counter, and that really change count is just going to be distributive, distribute change count, and increment is just going to be distribute increment. Is that right? We just need to import distribute. And we now collect, which is equal to collect default. And we need to import collect default. And counter. What? Following tag class members have not been implemented. G counter A, counter GA. G counter A, counter GA. Oh, distributive. What? Okay. And this can also go, and match counter with G. Oh yeah. Yeah. Okay. So that's our list. And that's our G really, right? And we need to apply the change count constructor, record accessor underneath counter, underneath unwrap. No, hold on. G is a list, well, some functor of things. So yeah, we need to go underneath, go underneath the list with fmap probably, right? Yeah, and unwrap, I think. And fmap that onto G. And do the same thing with increment. Is that right? Don't know. Unwrap fmapped to G. And how does this work in PureScript? PureScript record accessor. Underscore dot blah. Underscore dot change count and underscore not here. Underscore dot increment. And then unwrap from again from data new type and not by type G4 with function int. So here I was just hoping that distributive would have a function instance and that I could therefore, without needing to do anything, go use distribute and it would just work. But maybe I need to fmap again. No. Into T0. Okay, when I unwrap, I'm fmapping onto G. G is, let's say, a G of counter. So now this function is acting on the counter. I unwrap, I get the record. I underscore dot change count, I get into, yeah, I get into A at this point. And now I'm trying to distribute I'm hoping to get, I have an int A underneath a G. And I suppose I'm trying to distribute that whole thing. Okay, that's a different error. And then do I need to do the same thing here? Maybe just that. No. Oh, but GD0T2 with A1. That's not terrible. It's also hard to understand. Let's try and indent this differently. Trying to match type G0 to of G0T2. Let's try and see whether we can get some intermediary types to help us. We want this to be counter of, well, actually we want this to be int to G of A. Isn't that right? It is right, but we're going to struggle with our A's and so on, like we did earlier. Maybe not if we use the annotation. We shall see. And I is G of A. And I is equal to this. And type variable f I as counter A and counter GA. And GA type variable G is undefined. So That's unfortunate, but maybe it will work. No, it won't work like this. Okay, for all G is really what we want this to be. So, and for all A as well. Okay. Not really for all A, but we want it to be the specific A. But I think that's maybe it will work for all A. No, I don't think so. I think we're confusing the type checker there. Unfortunately, we can't link these things that I know of. At least not with this version of PureScript or something. Okay. When we fmap that thing, the G kind of goes, the G stays as it is. And underneath it, we unwrap and increment. Maybe we can find some example. Distributive, PureScript distributive instance for, I mean, this is close, right? For record new type or something. Instance for records. Blah, 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 blah. This is really old stuff. We want distributive, so I'll put this in quotes. Stuff. What's that? Okay. No distributive. So, no thanks. Maybe there's some examples actually in data distributive. Maybe we can look at the existing instances. Double from unit map second. That doesn't feel very right. I could try the collect way again. There is unwrap here, but it's not using a distributive instance for anything underneath. I suppose I could look at the Haskell distributive instances. In fact, maybe not with the co-free, just the functor one, which should be fine actually. It would actually be nice to add the functor instance and then it would be done, wouldn't it? Wouldn't it? Would it? If I added the functor instance to this, yeah, it would. Okay, fine, let's do it. That would be a reasonable contribution, I believe. Okay. Okay. Yeah, that would, I suppose, make more sense, right? Oh. Oh, yeah. Okay. So we're saying, let's write the functor instance. Instance func distributive functor f distributive functor f what f a where, and then we just copy paste. It's not hard. Co-free functor y. Okay, distributive. Okay. Why am I in Comonadic co-free? I don't know. Oh, what? Is that where I was? Okay, I think maybe I'm hallucinating in a gentle manner. Is there such a thing? No, of course there isn't. Why would there be a generic? But there is like a generic key thing. You can, if you can have products when both things are distributed, that should actually help us there. So we won't be able to do it for. How could we do that? I suppose we could do it with products. We could also try and see whether we could do it with generics in PureScript, but I think that's too much. We could do it with new type. Let's go check out how this works. New type. New type TA. So I think new type TA should work. No, collect equals collect default, and distribute equals pretty much this, right? We need coercible. No, that's fine. So A to T, so wrap of map unwrap, and yeah, no, we need to Spago install and whatnot. Yeah, we need to make it into a Spago thing. Okay. Identity. Is that true? Isn't that in functor or something? No, it's an identity. Okay. Identity, tuple. Right, these things are all separated like that. Our type equality that I'm ready to, yeah, believe. Type equality. I don't understand why this doesn't convert that, the Bower. And new type. Let's do the Haskell thing and new type. Tuples, I believe. Yeah. And data distributed has been defined multiple times, apparently. Am I importing distributive here? I am not. What's your dealio there? Duplicate modules. We are importing distributive, so that's not gonna work indeed. That sucks. There's some dependency. Okay, maybe we don't need any of that stuff. It could be that install. Okay, let's remove things and spago install. It's still copying distributive from the cache. Yeah, so one of these modules is actually dependent. Let's find out. So identity, that would be weird, but maybe no. Although who knows, right? What if control did? It does not. And what was the other one? Foldable traversable. That's more possible, right? But it doesn't. Except if by functor it does, and it doesn't. Okay, so maybe type equality then. No, console and new type, and those are depth dependencies. So don't tell me tuple does. Tuple does. Is it because tuple defines its own distributive instances now? This is version what? 5.10. Could it have been changed? 601 power doesn't depend on distributive, so it is a package version issue. What about 60? It did not, and 5.1 then must be the latest one that did. And could we revert to maybe 5.0 then? No, we couldn't. I see. So we could override it in package.dal, and wouldn't be amazing, but with tuples equals dependencies equals control. tuples is the source repo, and version equals v601. Oh, it could be 61 probably, right? No, 601. And Spago install. And we need to remove Spago and Spago install again. There we go. And no circular dependencies this time, and we just need some generic stuff. Generics. I think maybe it's not just generics. I think it's generic something. And effect. And console. That's a dev dependency, but it's fine. And yeah, generics is I forget pure suit and generic is to be created, and it's deprecated in favor of generics wrap. And it seems we build a bit more, and we're probably going to have a problem with our instance, but we'll see. And yeah, I think yeah, no class new type. I see. That's because we need to import class new type, and then we also need to import wrap. Then we have overlapping instances. We do. Okay, is it because I need to say new type? Then I need the constructor, but hold on. No, I think I meant what I said. What's the deal with that? Is it a... Maybe I get it for free? Tuple, okay, maybe I get also that instance for free. Is it new type TA? I don't know what the new type instances are. Okay, I'll keep that one around. That's Haskell. Pursuit and new type. Dependency, PureScript new type. 1 second. PureScript distributive depends on PureScript new type. There's something I'm not seeing here. Why? Why does it depend on PureScript new type already? It does use wrap and wrap for identity. That's how. That's why. Okay, that's fine. But yeah, so we need to go back to trying to understand new type. If there's some new type instances for tuple, then maybe it makes sense, but they're not here. Nor here. So that's really weird. And but maybe it's what I understand. What I don't understand correctly is the signature. You type TA. Maybe it's not some other thing. Additive AA. So distributive T. And that's overlapping. I suppose it makes sense. There would need to be Is it not possible to define pure script instances for new type class? There's a new type. Can do a new type instance. Is it that I need to work with generics really? It could be. Is there? Maybe there is already a distributive instance for generics. So let's go take a look at that. Because in that case, I suppose I can just derive the records generics map. Oh, that's deprecated in 0.14 though. Yeah. So we're not there yet. Okay. Let's check out generics rep. And yeah, no distributive here. I suppose it is kind of hard to do generically. Does it exist in? Yeah, only for products and composition, but I see. So okay, maybe we can't derive things too generically. Could I define it on the row type? I mean, I wanted to define it on new type so that I could unwrap the counter, right? Okay, I think I'm definitely fading, and I'm going to therefore try and wrap that up and leave it for next time. So let's see, what are we doing? Ongoing. At the lower level, we're trying to write a distributive instance for new type, then product types for counter AB. Go free base functor. The reason why we're doing that is because we want to go from list co-free to co-free list array in list off in list.list. And the reason why we want that is because we want to use component f instead of component w. So we need to rewrite the combinators, rewrite React Explore combinators to use component f. And the reason why we're doing that is because we're trying to write explore using explore m. Oh, a spammer joining us toward the end. Bye bye, spammer. Because we want to write explore using explore m, so that we can have the interpreter we want, i.e. an f ab to g a to mb. And I get a what do I get? Candy, a badge, clapping, slow clap. I get slow clap if I got this right for the type of the interpreter. If A to B, G to G A, explore, explore M, F A to B, G A, M B. Yeah, and we know we'll need to flip that like explore M prime, because we want to flip the co-free and the free. Okay, so that's what we'll do next time. Thanks a lot for watching, and see you on Saturday afternoon for more. Ciao, ciao.